Hello and welcome to this session. In this session, we will examine the troubleshooting faults in an LCD or LED TV. Additionally, we will equip you with the knowledge to locate and address issues effectively. Let's begin this informative journey together.
Objectives. At the end of this session, you will be able to identify the no power issue faults in the LCD or LED TV, rectify the fault in LCD or LED TV using the flowchart method, and test the TV after debugging. Let's first look at the tools and materials needed for troubleshooting faults in an LCD or LED TV. We will need the following tools, equipment, and instruments such as Trainee Toolkit 1 set, digital multimeter with probes 1 number, magnifier lens 1 number, capacitor discharger 1 number, color pattern generator 1 number, blower 1 number, soldering iron 1 number, and desoldering pump 1 number. We will need the following materials and components: ESD sheet 1 number, soft cloth 2 numbers, HDMI cable 2 numbers, RCA cable 3 RCA 3 RCA 1 set, optical cable SPDIF 1 number, coaxial cable 2 RCA 2 RCA 1 set, cleaning brush 1 number, IPA cleaning solution 1 bottle, and fuse 1 number. First, let's test the LCD or LED TV to identify the fault. Keep all the tools and materials required for troubleshooting the TV ready. Begin by positioning the television on the testing table. Now use the remote control to power the television. Switch on the TV using the remote controller. Then check the different patterns using factory reset remote. Observe the front panel of the TV for the LED indicator. If it does not illuminate, this indicates that the television is not receiving power. Now start by placing a soft, non-abrasive cloth on the repair table to protect the television's screen from scratches or damage. Then proceed with the steps to access the internal components. First, ensure the TV is powered off and disconnected from all power sources. Carefully remove all connected cables. Now focus on the back panel cover. Identify all screws that secure it in place. With a suitable screwdriver, methodically unscrew each one, storing them safely for later reassembly. After all screws are removed, gently lift the back panel cover away. Here is a safety tip. It is advisable to do this gently to avoid damaging any internal components or the casing itself. Next, let's get into the troubleshooting procedure. Upon removing the back cover, we are now able to observe the various internal sections of the LCD or LED TV. Take a moment to visually inspect the layout and condition of the internal components, including the power supply board, main board, and connection cables. Refer to the provided flowchart as our guide for systematic troubleshooting. For this, set the multimeter to continuity mode. Using each probe, check the power cord. Listen for a beep or check for low resistance. This signals the cord's proper functionality. Our initial test confirms that the power cord is operational, laying a solid foundation for further troubleshooting steps. Now we will explore the power supply board. First, identify the power supply board within the internal layout of the television. You can recognize it by the array of capacitors, inductors, and connectors typically located near the power input. Once identified, carefully detach the two main cables connected to the board. These are usually marked and may include the main power cable and the cable linking to the main board. Here is a safety tip. Ensure that you gently disconnect these to avoid any damage. Handle the board cautiously due to the fully charged capacitor. Use a discharging tool to safely discharge the capacitor by connecting the cables from the discharging lamp carefully. As the fuse is working in this case, the capacitor won't charge and the lamp stays in an off position. But if the fuse is not blown, the capacitor charges up and then the lamp lights up as the capacitor discharges. Next, we will inspect the fuse. Begin by locating the fuse on the power supply board. It is typically a small cylindrical component, often glass or ceramic, with metal caps on either end. To test the fuse, we will use a multimeter set to continuity mode. This setting helps determine if the fuse has a continuous electrical path. Attach the multimeter's probes to both ends of the fuse. In a functioning fuse, the multimeter should register a change from 1 to 0 accompanied by a beeping sound indicating continuity. However, in our scenario, if the multimeter continues to display 1 without any sound, it signifies a break in the circuit within the fuse. This condition confirms that the fuse has blown and needs replacement. To commence the replacement of the fuse, first we need to carefully remove it from the board. This involves a delicate process of desoldering. Use a soldering iron to gently melt and remove the solder attaching the fuse to the circuit board. Here is a safety tip. Ensure that you apply heat precisely to avoid damaging nearby components. Once the solder is removed, you can lift the old fuse from its position. Now prepare the new fuse for installation. Verify that it matches the specifications of the old fuse in terms of size, type, and current rating. Position the new fuse in place on the board, ensuring correct alignment with the circuit pads. With the soldering iron, apply a small amount of solder to each end of the fuse, securing it firmly to the board. Be sure to create a clean solder joint to ensure good electrical connectivity and prevent future failures. Now let us check if the power supply board is working using a multimeter. So examine the description near the connector of the cable leading to the LCD or LED TV. Ensure that the voltage indicated matches the required specifications for the TV. The same voltage should be visible at the end of the cable when checked. Connect the AC socket to the power supply board of the LCD or LED TV and power it on. Carefully explore and test various voltages to ensure proper functionality. Using a multimeter in voltage mode, place the probes on each terminal of the power supply board and carefully record the readings. If any terminal shows a voltage reading close to 0, it indicates the need for power supply board replacement. In power supply board testing, only 3.5 volt pins come alive. Next, proceed to conduct a thorough inspection of the main board. Connect the main board and backlight cables to the power supply boards. Then connect the AC socket to the power supply and switch it on. Next, using a TV remote controller to power on the television, closely observe whether the LED light turns on. The activation of the LED serves as a confirmation of the main board's proper functionality, ruling out any potential power-related issues. Sometimes you may encounter a no display issue despite completing prior troubleshooting steps. In such a case, refer to the provided flowchart as a systematic guide for further diagnosis. Begin by confirming the functionality of the power supply board, ensuring all voltages including the 24 volt. If the power supply board is operating correctly, proceed to inspect the functionality of the power button on the front panel. Replace if found faulty. Next, assess the performance of the IR receiver. Replace if necessary to restore signal reception. Lastly, verify the main board for any signs of damage or malfunction, ensuring all connections are properly secured to facilitate TV startup. With all previous tests affirming the correct operation of the TV, it can be confidently concluded that the device is in optimal working condition. Now let us reassemble and test the TV. Use a screwdriver to securely attach the back cover onto the TV. Position the TV upright on the table, ensuring stability. Verify that the patterns displayed on the screen accurately correspond to the selections made using factory reset remote.
This brings us to the end of the session. In this session, you have learned to identify the no power issue faults in the LCD or LED TV, rectify the fault in the LCD or LED TV using the flowchart method, test the TV after debugging. Thank you for watching and see you in the next session.